Okay, so we're back, and in this video we're going to discuss the rest of the lead pipe situation that happened in Flint, Michigan, and then also expand it to a few other places. So, how much did it cost, or would it have cost, to save Flint, Michigan's water supply from having all the pipe corrosion problems that it had? So your answers were $1,440 or $1,400 or $14,000. The correct answer was for about $140 per day. This whole thing could have been averted. So some of the national figures, I had to make a few notes here. So the actual cost to remove the Flint water pipes that have lead in them and replace them, along with all the other corroded pipes that occurred in Flint, would be about $55 million. This whole issue raised so much awareness, though, that some people were saying that we should remove all the lead pipes throughout all American plumbing, at least the public water infrastructure. So there's a bill for that ranges from a few billion to $55 billion. So it's a tremendous amount of money. The next thing is some people said, well, our whole water infrastructure needs repaired nationally. And if there was to be any investment in that, the total of repairing our water system and getting it up to where it needs to be is $385 billion. So we're talking about over $1/3 of $1 trillion to fix our drinking water infrastructure that was made, and much of it was made and paid for by the folks that were alive, especially from the 1940s into the probably early 1980s. Those folks were the folks that probably spent the most amount of their resources on upgrading our drinking water infrastructure, mostly through their taxes and through the rates that they were paying. And then lastly, another factoid about Flint, Michigan. With Flint, the actual liabilities on the state government because of that situation are about $1 billion, because there are all kinds of downstream effects of unintentionally or ignorantly, negligently poisoning a bunch of people with lead. There's going to be potentially increased risk of crime because of more violent behaviors. There's the potential harm or likely harm from neurological aspects of development for children, their education levels. There's fear. There's a lot of other issues that go into that calculation of $1 billion in liabilities to the state government. It could have been avoided by just spending $140 a day. So it's kind of sad. So what makes water corrosive? Why would they have needed to do this? So getting back to the slides here, how would a water plant know if their water is corrosive? Well, there's this thing called the Langmuir Saturation Index. So you can see pH is in this formula. We've also got a pK, which is a constant. Calcium, which you guys may remember, makes the water a little more hard. Another constant, the log 2 times the alkalinity here. We have this gamma term here. So this looks pretty complicated, right? Measuring the calcium, the pH, the alkalinity, we can do that in the lab. And then these constants, how do we figure that out? What's gamma? So it's not that hard for a water plant operator, actually, because groups like the American Water Works Association have made these math corrosivity estimators. They're free. They're available in Microsoft Excel format. This isn't new. This wasn't before Flint. This didn't exist. Most water plant operators pay attention to their corrosivity. What is believed that may have happened was they knew that the water from the Flint River was corrosive. When they switched from Detroit Public Water to the Flint River, they knew that the Flint River's water was corrosive. Why did they not add the anti-corrosion agent? Well, they didn't think that they would need to worry about it too much, because within a matter of about a year, they were going to open up a water plant on Lake Huron. And the water from the Great Lakes in general is not very corrosive. So they didn't think that they would need to worry about corrosion control with the Lake Huron water. So they didn't add it. And within a matter of months, the pipes were already corroding extensively from the Flint River. So that was a bad judgment call. And in Richmond, the Kentucky River, it's got plenty of calcium, plenty of alkalinity to it. And yet, our state, they require their water plants to do corrosion control. I don't think it's optional. So we do it. They could have been doing it. And it was probably negligence, and there's lawsuits and everything else that are out there because of it. And why didn't they do it? I don't know what the truth is ever going to come out to the public, but there's lawsuits involving it. So the Langmuir Index, how do you interpret your result from this Excel sheet or from that formula? So the Langmuir Index has a scale, and the ideal range is between negative 0.3 and positive 0.3. And it can keep going further than like 0.5. It can go up, to 0.7, 1.2, 3.0. I mean, you can have water that's got a lot of pipe scaling. You can also have water that has a lot of corrosion. So what is scaling? So scaling is kind of the buildup. You might think of like calcium in like a bathtub or a shower. Well, over time, a lot of calcium builds up enough of it. It will actually build up and create a big barrier. It's almost like a rocky layer, and you can actually clog your pipes up. Corrosion, though, is when the pipes start getting eaten away and they start getting flaky and they form all that rust that often lines the inside of them. So corrosion numbers are negative on the Langmuir Index. Scaling, which is on this side, positive numbers are scaling. Ideally, we want to be in this range so we're not building up too much calcium, and down here so we're not taking away too much of the pipe. As you get further and further on the corrosion scale, your pipe degrades more and more and more. So next, what if you're a private water user? Remember, what makes something a private system? So if this is your well, you're not treating it for like 25 or more people, right? So what do? Who's going to do the corrosion testing for you? Nobody. It's either you or no one, or you pay a lab to do it. Most people aren't going to do that. So if you're living on a private water system or have a low income, what happens to you? So we don't have a lot of groundwater measures in Kentucky of the Langmuir Index that's been determined based upon the USGS data. But you can see all around us here in Virginia, East Tennessee, groundwater has low Langmuir saturation indexes. So very soft water in many cases. The mountains, the Appalachian Mountains, all the stuff that was easily dissolvable, like limestone, a lot of it already dissolved and went with our streams. So we have a lot of hard sandstone rock that doesn't dissolve, doesn't have as much calcium in it as parts of like, Western Kentucky and Indiana and Ohio. All these areas over here where we saw all the hard water, many of them actually have scale forming potential. So what about here? So we worry about this region also because our life expectancies for a lot of health related reasons that are smoking, low income, diet, all that stuff. So our service region's that same area. So I was concerned about the lead levels potentially in some of the groundwater users, so I pulled some of the USGS data from Letcher County. Letcher County is this county that's down here, right here. And I was thinking that because of the mountain soils and the low pH, that the water would be more corrosive. Not a lot of calcium maybe, not a lot of alkalinity. And that I also thought that the lead levels would be negatively correlated. So as the Langmuir Index says more corrosive, lead levels would go up. So what do we find out? Well, before what do we find out? You can download groundwater data from USGS's partner here in Kentucky. They provide money to Kentucky Geologic Survey that operates out of the University of Kentucky. And the University of Kentucky's got these databases where you can download data for wells in various counties in Kentucky. And I was interested in wells and springs built before 1988. Why was I interested in wells and springs built before 1988? Because they were allowed to use lead in their plumbing. They could weld pipes together with lead. They could potentially have lead pipes even. So I was interested in pre-1988 water systems. I also emphasize Letcher County because Letcher County's got a lot of groundwater users. Most of the homes were built before 1950 or actually before 1980. So 26% before 1950, another 39% in this era. So just between them, you're up to, what is it? 39 plus 20 is 59. So we're at like, 65% were built before 1950 or actually before 1980. So it's a lot of them. Most of the people in the county at the time of this were groundwater users, private groundwater users. The income levels are not the best, so they can't afford to pay for these tests. So what did we find out? The pH, the medium was actually pretty good. It was 7.4. The range, there was some acidic ones, but most of them between 7.0 and 7.7. So most of it's alkaline or normal. The alkalinity levels, here's that range, hardness. Overall, the water, in my opinion, is not very hard, but kind of moderate. This is kind of where we want to be. 310. When you start getting up to like above 500, that's pretty hard water. Secondary standards kick in around 500 for total dissolved solids. The median Langmuir index, 1.7. The upper range, 3.7. Some as low as minus 3.3 when you calculate it from their data. Remember, balanced water, ideal water is here. Only 2 of the samples that were pulled from the USGS data, only 2 when you do the Langmuir index calculation met the balanced water level. Most were actually scaling, where the pipes could build up with material. A few, only 4, actually presented a corrosion risk. The state also had lead levels, copper data, and manganese for these wells as well. And most of them are well below the lead levels that we want to see, or we don't want to see. So it used to be that you wouldn't want to see more than 15 parts per billion. So there's a few that are above 15 parts per billion, but overwhelmingly, the majority are well below 15 parts per billion. All right, copper levels were pretty consistently low. Manganese levels, when you get over 0.3, we sometimes worry about neurologic effects, but there's no health standards on it. There was a health criteria advisory level, but overall, only a handful of them had really high manganese levels. So most samples pretty good for lead. There were 2. If you're those 2 people, that wouldn't be a good thing. All right, manganese levels, there were 6 of them that were above that expired health advisory criteria level in this little case study in southeastern Kentucky. The relationship between lead and Langmuir saturation index. So as our Langmuir saturation index went up, the lead appears to have went up. So actually the scale forming water had more lead in it than the non-scale forming, the corrosive water. Most samples are really good, but these 3 are associated with scaling. When we're above 0.5, we expect scaling. So lead was actually leaching out or in the water in some way from the ones that had scaling. So the hypothesis that corrosion was a problem in this county didn't seem to pan out. So we didn't have any evidence that corrosion was linked to higher lead. So that's a good thing. But for these folks, there's some other questions that need to be asked. Copper in the water, there was only like 1 that was a problem. And it was also one of these samples that had really high lead. So it makes you really wonder about what's going on there. So overall, I'm not going to spend a lot of time on that. For more concern on private water users, 62% of these houses said that they couldn't even remember having their well tested. 38% who had their water tested couldn't remember it being tested in the last decade. So those are all big problems. All right, so I'm going to stop it there. That's Ben Chariot. We had a lot of projects we were doing in southeast Kentucky and Kenya leading up to this. So that's why Ben's in the picture there, because Ben and I worked together a lot. He was an MPH student. Now he's got a really good job in Atlanta with the USFDA. So those are all the things we got going on here with this respective video. I'm going to email you guys the exam, and you'll have probably 8 or 9 days to get it done. And if you have any questions, you can email me at jason.marion@eku.edu. So I hope you have a wonderful evening or morning whenever you choose to watch this.